Right, week 10, video 9, the story of OO continues with the second of two videos on inheritance. So what I did in the last video, just to remind you, we had a class person, which was kind of similar to the ones we'd slowly developed in the first few videos. And then we introduced a new idea that we can write a new class, which we say is a subclass of another one. So the class student is a subclass of person, and we also say inherits from person. And this new class has an additional value being passed in, a parameter being passed into the constructor, the initializer, and we store that as an instance variable, and it has another instance variable which is a list of courses the student is enrolled in. We also added a new method to enroll a student in a course. So just to demonstrate that, first of all I'd better run it. If I then go stud is the student Mary, who lives somewhere and is of some age, 219 is a bit old, and has an ID number of some sort, then I can do the stuff that I could do with a student. So I can print, with a person, I can print the student, but it prints as though it were a person, not as a student, so that kind of looks wrong. I can greet the student or ask the student to greet me or something, stud.greet, hello, my name is Mary, and I can also enroll the student in a course. So stud.enroll in course cosc121. And once I've done that, then the stud.courses for that particular student now includes cosc121. So there's two things there. There's the new method I've added, and I can still make use of the existing methods that we inherited, both the repr and the greet. Now, one of the things I mentioned in the last video was that I had repeated some code here which was ugly, and I don't want to do that. That's the code that we saw in the first 3 lines of person. So wouldn't it be nice if I could avoid that? And of course I can and should. So I should take those lines out, and I should instead make use of the superclass initializer. The way I do that, or the first way I can do that, is to say I want to call the init method of the person class, my superclass, with the same set of parameters. Now I can't pass in student ID because that doesn't initialize. Persons don't have student IDs, just the 3 that they do accept. So here we had self, name, address, age. I've just passed those ones in, and all that I add is the ones that are student specific. So that's a much better piece of code, and that works too, and I won't bother demonstrating that. You can try it yourself, make sure it still works. There's another way I can do it, which is worth pointing out. It's possibly a little bit odd. I can go super, and super is a kind of funny function which creates what we call a proxy superclass object. So it creates or returns an object that behaves as though it were an object of the superclass, in this case person. So I call that one's init method, but now I don't pass in self, which is a little bit confusing, just as I don't pass in the self object when I'm calling methods of an object such as a color. I can go color.lightness, or I can go, that's one way, or I can do the color classes lightness method called with an object color. So same thing here, I'm just doing it in this case with this object, which is a superclass object. So there's another way that works as well. So the other thing I noted was that so I'll just check my slides here. So that slide has now been covered. And the other thing that I wanted to mention is you don't have to stay with the methods of the superclass object, and in particular I didn't want to use the str method of the person, because the str, or repr in this case, method of the person says that they're a person, not a student. So I should really replace that with my own student specific version. So I should paste in here that the repr of a student is the word student, and following the model that what I should print out is the same sort of string I would use to construct one. So I just put in the student ID here. So with that modification, if I create my stud Mary again here and print the student Mary, what I now get is student Mary ASDF 21. Probably should have put some quotes around that, but never mind the details. I forgot, hang on, that's not right. What happened to my, oh, I forgot to print out the extra parameter. Let's try that one, rerun that, create Mary and print Mary. Now we get the student ID for Mary. Okay, so that's called overriding. There's another example in the lecture notes which you may want to type in and try yourself, which overrides, instead of overriding the str or repr method, it overrides the greet method in a kind of silly way. This actor, who's a subclass of person, greets you by greetings and felicitations from the maestro, Kenneth Branagh, for example. So some people would say that's stylistically questionable because why should a subclass of person behave so differently with regard to a simple thing like greet? String, yes. Greet, no. Maybe. I can't be bothered arguing that. It's a real detail. You may be wondering when to use inheritance, and there is an important rule that I want to hammer here, which is that you only use it if you could use is, are in ordinary speaking about such a thing. So you can say a student is a person, no problem there. You can say a rectangle is a drawable object in some graphics program. You can say a value error is an exception, that's fine. Science course is a course, but you cannot say, for example, a course is a list. So a course has a list of students, but it isn't a list. So some people, when they're learning inheritance, misuse it. They use it as a way of sort of fudging up stuff to save themselves having to write some extra methods. They missed it. Well, I don't want to get into too much detail. OO design isn't the primary topic in here. So a person isn't a fish, even though they can swim. So is-a is the key to inheritance. And you can actually check in whether something is a member of a certain class, so that, for example, if I've got x is 5, I can use the isInstance function, it's a global function, and I can say is x an int. So the first parameter is an object, the second parameter is a type, and I get true. I can ask, is x an object? Remember, object is a class, a little bit confusing. Is x an object? Yes, it is. So isInstance returns true for everything along the inheritance chain. So in this case, if you asked, is academic a person, you'd get a yes. Is academic a staff member, you'd get a yes. Is a staff member a person? An instance of each of those, I should say. Is an instance of academic a person? Is an instance of a staff member a person? However, where am I? However, please don't do or try to avoid that if possible. I've got a style rule here, isInstance is evil. I can give you a sort of analogy of that. If you want to know whether somebody is male or female, you can check their birth certificate, but that's not considered the courteous way to do things nowadays. The courteous way is to let them identify their gender. So you provide a method where an object provides you, or a person in this case, provides you with their gender when you ask. And that's the kind of courteous way of doing. You don't ask, you don't use this as an instance function. If you want to know if something is an integer, then you ask them. So you have a method of the object which lets you ask that question. So like I say here, if you find yourself using this, you're probably lacking a method which lets you interrogate the object itself. Very much, again, a detail. So that's all I wanted to do in this particular video. I was introducing two new ideas, or a couple of new ideas really. The idea that how to initialize subclass objects, how to override superclass methods. Thanks for watching. Bye.